I want to walk through the steps of how to solve this problem. The first thing that we need to realize is that our P, that has already been stated, is going to be a 0.62. Our N was 225. And you have actually already found our sigma P hat, which you found by taking P times 1 minus P divided by your N and taking the square root of this. And you found that to be 0.0324. We're going to use this in this particular problem. Now, looking at this, I'm going to draw my curve, and it's going to be a little bit of a normal curve. And so I'm going to put a 0.62 in the center, because that's my middle, that's my mean. I want between 0.55 and a 0.67. Okay, so if I put a 0.55, it's going to be somewhere over here. 0.55. And my 0.67, well, it's going to be somewhere over here. And we want everything in between. So what we have to do is we have to calculate the z-score for both of these values. And if you recall, the z-score is going to be our p hat minus our p divided by our sigma p hat. Okay? And so we have to do this for both of these values. So I'm going to scroll down a little bit, and I'm going to start with the 0.55. And so I'll take 0.55 minus our mean, which was 0.62, divided by the standard deviation, 0.0324. And we calculate this, and notice that this is on the left-hand side, so I should end up with a negative because it's on that left-hand side. And so I do the subtraction first, and I get a negative 0.07, and I divide by a negative 0.0324. So for this z, I get a negative 2.16. So this is like saying here's a negative 2.16. Then I'm going to do the exact same thing with my 0.67. So I'm going to come over here, and I'm going to say 0.67 minus a 0.62 divided by the 0.034. And since it's to the right, I should get a positive. So that gives me a 0.05 divided by a 0.03, and I forgot my 2 there, 24. So I get a 1.54. Okay, so I have these two z-scores, and I'm going to redraw this down here a little bit larger so I can see it and be a little bit more accurate. So here's my 0, here's my middle value. Now, negative 2.16 actually is probably over here somewhere. Negative 2.16. And a 1.54 maybe over here. What we would like to find is actually the center part here. So what we have to do is we actually have to look up these values on the z-chart. So if I look up a negative 2.16, I'm going to come over here to my z-chart, and I'm going to come down to a negative 2.16. So here's a negative 2.1, and I'm going to come over to the 6, so here's 0, 1, 2, 3, 4, 5, 6. Here's a negative 2.16. So I get a 0.0154. So remember that our chart always gives us to the left. So to the left of this is a 0.0154. Well, that doesn't include any of this. That's okay. We'll figure out what happens here in a few minutes. Now I need to look up the 1.54. So I come back over to my chart. I scroll down or flip over to the positive side. And I go over to the 1.5. And I come over to the 4. So here's 0, 1, 2, 3, 4. And so I get a 0.9382. So that means that from here left is a 0.9382. Here's the issue. I just want this part. So what I'm going to do is I'm going to take this number and I'm going to subtract out this number because I want to cut it off here. Okay? So anytime I want a between type of situation, I'm going to take this one that's on the right, I'm going to look it up, and then I'm going to subtract, after I have looked it up, the probability that's on the left. But I have to look them up on the table before I can do that subtraction. So I'm going to take a 0.9382 minus a 0.0154, and this will give me a probability of 0.9228. This is the probability of being in between here, in between the 55% and 67%. Okay? So again, anytime that you want an in-between value, you have to calculate the z-score for both of those probabilities, or both of those values. Look both of those up on the table on this cumulative normal table here, and then you will subtract the larger minus the smaller of those probabilities. So let me know if you have questions about that.